Welcome back. This is the second of the three problems that I want to showcase to you in the concept of depression freezing point. Now, the problem I worked out earlier is really all you need to understand the concept of depression or freezing point. These type of problems is merely having you think, okay? Have you think about how you're going to set up the problem so you can get the desired result. And a lot of that knowledge that you need to set up this type of problem has to stem from your prior knowledge that you learned in Chem 170, right? So now the question is asking how many grams of glucose. Now this is your solute, okay? Would have to be dissolved in 1.5 kg of water. So this is your solvent. To lower the freezing point by this. What does it mean by lower the freezing point? As this is already your depression of freezing point. So this is your delta TF that's given to you. The freezing point constant is given, so this is KF. So ideally, first what you want to do is set up the equation. So KF times M times I, and find out what it is that is missing in this problem. Because unless you find that information, you would never be able to get to how many grams of glucose, right? So we know this, and we can get that, right? Glucose is a polar molecule, but there is nothing metal or non-metal about it, so I equals 1. So this right here is 1, right? So let's set this up. So the freezing point depression is 4.4, KF is 1.86, molality, well, we don't know. That's what we need to find to get to the final answer. And I is 1. So M equals 4.4 divided by 1.86, right? So 4.4 divided by 1.86. It's 2.36 molal, right? Now, what does this mean? Now, I have repeatedly told you when we learned these concepts in 175 is, instead of writing it as 2.36 M, write it in terms of molality. That is 2.36 moles over 1 kilogram of solvent, right? Now, to find the grams of the solute, we need to find the moles. Somehow we need to extract the moles of the solute out of this, right? So if we take this information and proceed further with the problem, it wouldn't be as hard, right? Now, if you keep writing it as 2.36 M, the problem might seem like, okay, I'm kind of hitting a roadblock. Where do I go from here? But if you instead write it this way, it makes a lot more sense already. Now, we know the answer in solvent is 1.50 kg. You can just put 1 here. So now we have extracted the moles of the solute from the 2.36 M, right? So times 1.50. So now we have found essentially the grams of, so essentially that's kind of what it's asking. Now this answer, this is in moles, right? This is moles of the solute, right? Now what do we need? We need the molar mass of glucose, which I believe is 180. C6H12O6 is 180 grams over mole. Now all this, starting from here, all the way to this 3.4, and what I'm going to do next, we have done it in Chem 170. So it's a knowledge, it's carrying over of knowledge that's very, very important. And that's the reason why I taught the course in a format where it's not like we learn anything in a compartmentalized fashion. We always learn everything in the context of everything else. So now we multiply this by 180 grams. So that times 180 would give us 637.2 grams of glucose. Now, this problem is also another way of looking at it. Now, let's say it's not apples and apples, but here we've used glucose, right? Imagine in the previous problem, we dissolved only 32 grams of table salt to lower the temperature by almost negative 51 degrees. But look how much sugar we need. 600, and again, this is not an exact problem to problem comparison. But what I'm trying to tell you is, in both cases, it's water. But in one case, we just needed 32 grams of table salt versus 637 grams of sugar. Now, for a city that's cleaning up, that's putting salt on the highway to prevent the road getting frozen, which one do you think is commercially more viable for the city? Would they want to spend 600 grams per square foot of the road versus 32 grams of salt? And sugar is actually more expensive in the store. If you go to the grocery section and you look at mortar salt, you know that bottle of salt costs about 35-40 cents, whereas a pack of sugar costs a lot more than $3. So 32 grams versus 637 grams. Now the government already, the city is looking at, as it is, it's expensive to put this, but to do it almost, you know, not even 2 times or 3 times, it's more than 10 times. Okay, 10 times is still 320 grams, so it's almost 20 times more amount needed for the same amount that this is sodium chloride, which is your table salt, and this is your sugar. Now, I've answered the question in another way, that you do need a lot more sugar, which is why we go for the salt over the sugar, right? Now, all this is important from a more conceptual perspective. Now, setting up this problem and getting it here, I'm sure all of you will get here. It's going from here to here is where a lot of you would struggle. But then if you're really struggling, that means you have to actually start to understand how to decode the M to moles over kilograms, and then you can set up the problem. All right, I've explained it in multiple different ways on this screen. So this is the penultimate problem. I got one more problem, which is a modified version of the previous problem that we did, and then we'll see if we can do it right. All right, so stay tuned.